Hello, dear students. Welcome to Camp Excel Physics. I am your instructor, Dr. Afnan. In today's lecture, we are discussing about significant figures. That is a very important and often misunderstood topic. So by the end of this lecture, you will not only understand significant figures, but you will also be able to find them, use them, and avoid common mistakes like a pro. So today's lecture is basically comprising of four contents that will help you to find out significant figures and understand the entire concept of it. So the number one is the basic introduction about significant figures, and under this content we'll be going to see why significant figures are important in physics and how they reflect the precision of our measurement. Number second is the definition of significant figure, in which we'll be seeing a simple explanation of what significant figures are, that is the combination of certain and uncertain digits in a measurement. Number third, we'll be looking into the rules to find out and to determine the number of significant figures in a measured value. So easy to follow rules that help identify which digits in a number are significant with examples for clarity. And number four, we'll be looking examples for practice in which we'll be going to try out real measurements, apply the rules, and learn how to count significant figures correctly. So let's start with the introduction of significant figures. In science, no measurement is ever perfectly exact, even with most advanced tools. Every instrument, either it is a basic ruler or vernier caliper, has a limit to finally it can measure, and that limit basically creates a small zone of uncertainty in every reading. So when we record a measured value, it breaks into two parts. The first one is certain digits. And what are the certain digits? These are the values you are fully confident about. And what does that mean? They are the reliable and undoubtful digits. While the second part is one uncertain digit, that is the doubtful digit. And that is to be estimated and we are not confident about. So together these digits, both certain and the first uncertain, they form what we call significant figures. So now we are in a perfect position to define significant figures. As the name depicts, significant means important, while figures mean digits. So significant figure is basically the combination of certain digits plus first uncertain digit. And as per the definition says, the digits in a number that carry meaningful information about its precision. And it includes all the certain digits plus the first uncertain digit in a measurement. So now we will be looking into the rules to find out the significant figures, and without knowing them, you won't be able to find out the significant figures in a measured value. So there are 5 rules according to which you can easily find out the number of significant figures. So according to rule number 1, all the non-zero digits, that is 1 up to 9, are considered significant always. For example, we have a number 1453. So in this number, you can see that all the digits are non-zero, so these 4 digits will be considered significant. And according to rule number 2, any zeros between significant digits will be considered significant. For example, we have a number 10002. Since you can see that there are 3 zeros which are in between two non-zero digits 1 and 2. So as a whole, there would be 5 significant digits, including the zeros which are in between the non-zero digits. Rule number 3, leading zeros. So first of all, we have to see what are these leading zeros. So they are the zeros which are to the left of the first non-zero digits, and they will be considered as non-significant. For example, 0.0034. So to the left of the first non-zero digit, that is 3, we have 3 zeros. and they will be considered not significant. So as a whole, we have only two significant digits in this number, that is 3 and 4. Rule number 4. According to these rules, the trailing zeros, so what are the trailing zeros? So they are the zeros which are to the right of the first non-zero digits, and they will be considered as significant if the number would be having a decimal point. For example, we have a number 45.600. Since this number is having a decimal point and has trailing zeros, so all the numbers, all the digits will be considered significant. So this number is having 5 significant figures. Rule number 5. The trailing zeros in a whole number without a decimal point will be considered as non-significant unless it is specified by a scientific or a standard notation. For example, we have a number 1500, 1500. Since it doesn't have a decimal point in it, so it has only two significant figures, that is 1 and 5. But if the 1500 is converted into scientific or standard notation like 1.500 into 10 raised to the power 3, so what would happen? This number would be having a decimal point, so it becomes 1.500. So the trailing zeros will be considered significant, and as a whole, this number would be having 4 significant figures. Remember one thing, the 10 power will not be considered as significant. So now we will be looking into a few examples on which we can apply the rules and find out the number of significant figures. So here we have an example number 1. So according to this example, we have a number 0.00780. Since this number is having a decimal point, so we can assume that the trailing zeros will be significant. But since we have 3 leading zeros, so according to rule number 3, they will not be considered as significant. While we have 7 and 8 which are non-zero digits, so according to rule number 1, they will be considered as significant, as always. And we have a trailing zero which will be considered as significant because this number is comprising of decimal point. So in total, the number of significant figures will be 3. Example number 2. The number right in front of you is 450000. So there are 6 digits in this number, but how many significant figures are? We have to see what rules say. So 4 and 5, they are non-zero digits. So according to rule number 1, they will be considered as significant. And since this number is not having a decimal point, so these 4 trailing zeros will not be considered as significant. So as a whole, the number of significant figures will be only 2. Example number 3. The number right in front of you is 97000.0. Since 9 and 7 are non-zero digits, so they will be considered as significant. And since this number is having a decimal point, so the trailing zeros will be considered as significant. So 2 non-zero digits and 4 trailing zeros, so as a whole, the total number of significant figures will be 6. Example number 4. 7.0004. So here we have the first non-zero digit and we have 4 as second non-zero digits. And in between these two non-zero digits, we have 3 zeros in between, and they will be considered as significant according to rule number 2. So as a whole, we have 3 zeros between non-zero digits considered significant. So a total number of significant figures will be 5. Example number 5. 2.30 into 10 power 4. Since we have 2 non-zero digits, 2 and 3, they will be considered significant. And since this number is having decimal point, So this trailing zero will be considered as significant, and we have already mentioned that the power of 10 will not be considered as significant. So as a whole, this number is comprising of three significant figures. So that's all about significant figures. If you found this video helpful, don't forget to like, share and subscribe for exciting and informative scientific concepts. Thanks for watching.